Awesome, guys. Welcome back to our Tuesday training. We're hanging out with the team here again every Tuesday. Just we've been doing these internal team trainings, and now we're just going to be publishing them on YouTube and X. So go follow us over there, and you can kind of stay tuned to how we're teaching different things on everything from shape up to breadboarding to how to use AI, how to vibe code professionally. These are all the topics that we're covering here. And so today we're kind of picking up on a part two from Jonata, who's one of our team members in Brazil. And he last week did an awesome training on kind of an intro to Flutter. So if you haven't seen that, go check that out. And today we're going to kind of wrap up that kind of introduction to Flutter, but also talk about how we're using Flutter specifically in Tribe Social, which is our main product we've been building the last few years. So we originally did have that project in Flutter Flow, and then we finally exited that and put it into Flutter. And now we've been kind of rebuilding and refactoring the whole project. So if you're working on any part of Flutter on our team, or if you're just curious how we're using Flutter for Tribe Social, this will be a good video. So I'm going to hand it over to Jonata.
So, hey everyone, nice to be here again. And for this session, I wanted to start with just like reviewing the key takeaways from last session, just so we are on the same page and to keep things fresh. And then we'll dive directly into how tribe architecture is currently looking like. And we'll review one specific case where we had to migrate from Flutter Flow code, let's say, to a more well-architecture and cleaner way of building things, and how we did this migration, and what are the key things we keep in mind while doing this kind of migration. So let's start. So reviewing the four main takeaways from our last session, basically, so Flutter has this cross-platform power. We build once and deploy everywhere, mobile, web, desktop, and it has a, I wouldn't say like a native performance, but a very close to native, especially on the mobile side of things. The Flutter rendering is doing a good job on this side. Of course, with some, let's say, with some differences depending on which kind of feature or which kind of structure you need to show. Like if you're going to be very animation oriented and you are going to need heavy animation, let's say, then sometimes you may see some type of stuttering, but that's not the overall experience. So it's a very stable cross-platform tool. Also, we have the widget first thinking. So like we saw in the previous session, everything on Flutter is a widget, and we compose complex UIs using simple reusable blocks using this declarative syntax. And this part of building using reusable building blocks is very important. And I will show how we think about it when we are migrating from the Flutter Flow generated code, which in general tends to generate a lot bigger than needed pieces of code, and how we broke this down into smaller and more reusable components that we can use across different places in the application. We also reviewed some of the Dart's modern features, so strong typing, null safety, how it's handled async and await, and asynchronous communication in general, and a few patterns that makes your code safer and more maintainable. And we also saw a bit of the state management in Flutter, starting with the most basic one, which is the set state, and going up to providers and pubs that are specifically created for state management. So that were the main points from our last presentation, just so we had them fresh on memory before diving into the next thing, which will be our Tribe Social app architecture overview. So here we'll take a quick look into how we are structuring things on Tribe side and how we are thinking about this structure. And one important thing to note here is that this is still a work in progress. We've come a long way with our app, and it had a lot of different phases. As any big production app that we have, we kind of it has its own stages and its own development. So the things we start with is very different from what we have now, and you see that a lot of this structure, a lot of our architecture also reflects the history that we have. So you see a lot of Flutter Flow legacy things, some decisions that were made in the past are still present, and we are always reviewing and updating things as we go. And the architecture is basically a snapshot of the current moment and how it's currently looking. So starting with the tech stack itself and how we are handling deployment, we use, of course, Flutter and Dart for mobile and web clients, targeting iOS and Android and web from one single repository. We use Firebase services like Firestore, Auth, storage, and cloud functions to handle our a part of the logic of application, and also managing the authentication. It's also important to note that we also have our own API that's built in separated from the Firebase structure, and we are currently looking to the future of migrating completely out of the Firebase and removing this dependency and only relying on our API. We currently have this dependency on Firebase because during the Flutter Flow phase of the project, it was a lot easier to have it integrated directly with Firestore, and this way you could leverage a lot of the Flutter Flow structure in terms of making it easier to access content from Firestore and to use it on the app using the Flutter Flow structure. But now that we are out of Flutter Flow, we have the ability to kind of gradually migrate off, at least from the backend side of things, from out of Firebase, and to be able to rely on our own API for everything backend related. But this is a long way. This is something that takes a lot of work, and the difficult part about refactoring is that customers usually don't see it. So it's a balancing game of delivering new features that customers will be able to use and see, and also being able to refactor these parts that we are touching. And here on Tribe, we try to do we avoid trying to tackle refactor as a project in of itself. So we usually associate the refactor with doing some feature related thing and improving on this feature. And if this feature is going to touch some places in the app that need some refactor for some reason, that need to for instance, remove some dependency, then we tackle them, we group them, and we use this as one big project. This way, we don't have like this huge refactoring sessions that could take months. We break them in smaller pieces that are more manageable and allow us for what I think is actually the most important part, to be able to do constant releases to our customers, and they will be gradually experiencing a better app in overall. So we have also Flutter Flow generated code that lives in the pages part and also on the component part of the app. But like I said, we are gradually migrating it from clean architecture inside the features tab, inside the features folder inside the project. And one interesting piece, and one interesting fact, and one interesting part of the Tribe's tech stack is that we have a flavor-driven structure that builds 9 different apps. I think it's 9 from my current count, but we build 9 different apps, launching different Firebase projects, bundles IDs, apps on the App Store and Android Store, and assets configured per flavor. So this is very robust structure that we have implemented using Code Magic, where from a single repository, we are able to deploy to 9 different apps, and we can easily add new customers to this structure just by setting up the configurations file that we have for Code Magic and setting up the assets. Even yesterday, I think Bruce, in one afternoon, was able to easily like 3 to 4 hours. Yeah, that's
Yeah, easily was
the one mentioned
maybe a bit
because
underrated, but yes, within a few hours we could set up someone new.
yeah, like but see, we are kind of spoiled now because now things are a lot faster. But in the past, like 4 hours was like nothing in terms of development. Now we can do a lot in 3 to 4 hours, but yeah, it's nice to have this structure in place, and even though it's not so fast, but it's still very robust and allow us for inviting new customers to the app and creating their own white label versions of Stripe with too much of a hassle. And like I said, we did it. Actually, Bruce did it this yesterday afternoon with a new client, which was very cool to see. So this is a very important part of the app, and you see that we try to abstract this from the code as almost as much as possible. So if you are walking through the code, you almost never see anything that will point to the fact that this is serving 9 different apps. So we have specific places in the app that we have created abstractions layers that allow us to touch as little as possible of the application if we need to have a new customer running. So like I said here, and here on the right, we have a little bit more of this multi-client architecture. So we have a flavor config, we have our CI/CD running with the flavor structure from Flutter itself. Flutter has this flavor system that allows us to generate different apps, and this also configures the Firebase for each customer. So each customer has its own Firebase, and this keeps the shared code clean while injecting client-specific dependence when we need it. So here below we have we'll see this a little bit more during our in Cursor directly, but here is, let's say, the main structure inside the lib folder, which is basically the main folder of the Flutter application. So we have the main, which is the entry point for the application. We have inside the config, we have the application configuration, including flavors. We have features, which are work in progress, let's say, migration folder, where we are refactoring things and moving into there. We have the pages with all the UI screens, mostly generated by Flutterflow, and we will see the difference between what Flutterflow generated code and how it's the code that we actually want, or a code that's more like what we want. These components as well are mostly generated by Flutterflow. We see how they look. The data layers, the backend folder with services for Firebase and also access to API. And we have a Flutterflow folder. And I would say that one of the main goals from migrating out of the Flutterflow, including this migration, is to eventually get completely rid of this folder, because this folder is just a dependency. has a lot of dependencies from Flutterflow maintained libraries, and it uses a lot of the structure that Flutterflow defines as ideal for their projects, but it's not what we think it's ideal for our own project. So our goal for the future is probably remove all dependency from this folder. This will probably be done in small steps, like I said, as we work on different projects and different features. Custom code is basically all the custom code that was generated, that was created inside Flutterflow. So in Flutterflow, we have the ability to create specific sections of code that are custom, and this can be called by our components, and all this code lives inside this folder. Auth is everything of authentication related, and app state is a legacy global state management from Flutterflow as well. So that's it for the main structure and for the key folders, key files of the app. Now let's move to how we are thinking in terms of the desired architecture for the app, and then we will see what's the current. Then we'll see a little bit of how we use also cursor rules to try to enforce this desired architecture, and finally we'll see the current state of the architecture and one example from migrating from the old architecture, let's say, to this newer one. So very basic. We have three layers in general. The presentation layer, where widgets, pages, and providers live. We have the domain layers with the logic itself, with the business logic, so use cases, entities, and a repository interface. And finally, we have the data layer with callings, with access to the Firebase/API, and the implementations for the repositories, for the interface of the repository that we defined on the domain layer. So going in more detail of which one, presentation widgets depend on domain contracts only. So everything that's on the presentation layer should only have access to what's on the domain layer. So that's the idea of avoiding having to add all the models and all the stuff, and to import everything that's on the data layer to the presentation layer. We don't want to create this cross-layer interconnection. We want to keep things as clean and separated as possible. So presentation layer only communicates with the logic layer that informs the presentation layer how it should behave and what information it should show. And the presentation layer itself is responsible for deciding how it's going to be shown, but not what's going to be shown. And that's the main difference between the two. So I think actually, I will wait until the migration part to show how it's currently looking on the implementation, just so we don't take a lot of time, because I have the tendency to talk a lot. So let's keep things short for this part. The domain layer defines the business rules with entities and use case, and it will never import the widgets related to Flutter or any of the Firebase direct code. So it's a cleaner layer with just the application business logic. And finally, the data layer implements the repositories that this in turn will talk to the backend and map the documents to specific entities that will in turn be used by the domain layer, and the domain layer will pass only the information that needs to be shown back to the presentation layer. So it's a very straightforward structure, and that and like I said, this is the structure we are aiming for. This is not what we currently have, but that's the overall desired state for the application. We have a lot of cursor rules that we use. And when I say cursor rules, you can take into account that this can be migrated to the Cloud Code SDK with its specific rules, or any other type of AI helper that you are using. Basically, it's the same thing. It's just a document of text that highlights what we want. So the clean architecture basically it's a folder specifying and spelling out the solid patterns and how this is applied to our project. We have one very interesting rule, which is the Flutter flow migration rule, in order to clearly define what we want when we are removing Flutter flow dependencies from the app, and what are the things that we want to remove. And we have some layer, which is the Flutter best practice, that's basically oriented to better widget composition, state handling, and single responsibility principle, which I think it's basically the main thing when we are thinking in terms of architecture, especially in the age of AI. I would say that good architecture is even more rewarding to have now than before. Like before, it was very important because we needed to someone else to be able to jump in our code and to find things easily, and we also wanted to be able to have the architecture on the back of our minds and to work with it in a simple manner. So if you have like a lot of interconnections and you don't have a pre-established structure, then you probably aren't able to create this house of cards in your mind of how the app should work. And when you were working, you probably would make decisions that were not aligned with the original architecture or with the desired architecture. And I think a lot of this go back to the single responsibility principle that now with the age of AI is even more important, where since we have limited context windows for LLMs, and even like 1 million context windows that we have now, it's not actually 1 million, because if you are going to try to add more stuff and go to the max amount of context that you can use, the model starts to get dumber. So the idea is that you want to create an architecture that you need to feed as little as possible of the architecture, of the widgets, of the files. You need to feed a little as possible to be able to get the model to understand your architecture and to be able to follow through the changes without exactly breaking into more small files rather than fewer larger ones. That's the best deal of the air for it. You want to have smaller files because they are easy to work with, even from a human standpoint, but also now from a machine standpoint. So very important to keep this in mind. Now let's go to the most interesting part in my opinion, which is this migration case study for the groups community feed. So the groups community feed is basically the main screen of our application. It's the feed that has all the communication that's happening, all the posts, all the lives that were recorded, all replaced. So everything that's important, not important, but everything that's happening inside the app tends to go into the community feed somehow. Exactly, that's very important. Lucian just mentioned one thing very important here on the chat, which is properly named functions, classes, and variables. And it's funny because that's even a meme. Like we take like X amount of time to create something, and then 2x the amount of time to name the variables for it. And I think this is very true. And I think this from someone who maybe hasn't worked with code could think that this is useless, and but it's one of the most important things that we have is like to have clear functions definitions, to have clear named classes, to have clear named variables. It makes your life easier, and it makes the AI life easier, because then, for instance, you can have just the definition of the function, meaning you have just the information, the title of the function, what it expects as a parameter, and what's the expected output. And with all the information, with only the contract information, you can make decisions about it. And that's the ideal the ideal image, or the ideal point that we want to have. We want to be able to just look at the name of the function, the parameters that it needs, and what's the return. And we want to be able to, from this, take this, use it, and take into account into our decisions just by the contracts. So now going back to the migration case study, like I said, why this page? Why we refactor it? So first, it had 1,094 lines of code, and for let's say just a feed, it was a big, it was a very big component. So this was, and it was basically all generated by Flutter Flow. So it was a key component from the app, and all the code in it was basically generated by Flutter Flow. So this was a lot. This was a very strong motivation for this change, and everything was built inside the build function of the widget, which is a very poor practice. Like when you read the build function of the app, it should be like quick, clean, and easy to read. And with just a glance, you need to understand, hey, by reading the build function of a widget, I want to be able to imagine what this widget will look like. And when you have like 1,000 lines of code, this is not possible, because you have paddings, you have other widgets intertwined with each other. So I will show the before and after for you guys to be able to have a more concrete example. But the monolithic build, they have dependency on the Flutter Flow app state management, and also inline Firebase queries were all things that were happening inside this component that we got rid of. The refactor component now has 429 lines, so less than half, and has helper methods, extracted sections, and testable streams. And a few of the highlights was, first, the UI was sliced in different focused widgets. So instead of having one big widget, we broke this down into feature content section, category filter section, create post section, post list section, all listed under the group components page, groups component folder. We also centralized the logic of the life cycle inside the initialize page data and show update dialog if needed. So as you can see, just by reading the function, you can imagine what they do. One is for initializing the page data, so pretty self-explanatory. And the show update dialog if needed is basically it. We have a dialog that asks the user to update the app if they need to update it, instead of scattered around the schedule by their callbacks. That it's a thing that Flutter Flows relies a lot. And we have a model for delegating the updates to the selected category with a local set state, avoiding the global state churn, because it was previously dependent on that app state, of that Flutterflow app state management system, and we replaced it with the simpler option that we have with the set state. So this was a very interesting change as well, and it helped a lot. So the difference walkthrough, let's say, so pre-refactor the feed used a paged list view with paging controller, mixing Firestore queries with widget concerns, which is very bad. Like when we are in the presentation layer, we want to be seeing just UI related stuff. We don't want to be seeing like queries and logic, and that was what was happening. Uh, and
Yeah.
Bruce.
No, this is great. I was gonna say, like, maybe you could dig into that a little bit because um so the like backstory on this particular group page had been a pain point for probably a year or two. It's like we're making a social media app. This is the feed. It is kind of like the whole app in one thing. And we've probably spent months and probably over like a few hundred hours optimizing this page to get it to work better. And so we're inside of Flutterflow, that is. And so once we moved it out of Flutterflow, obviously weird. I mean, I think this maybe, what did it take, like a week or so?
Yeah.
Yeah, it wasn't a long time. So um had we known this, sooner, we could have pulled it out of Flutterflow sooner and maybe got some better results faster. And it really comes just when you're using these low code tools, it does take there's so many layers of abstraction, so you just end up looking at the design. And we had some pretty smart people, including yourself, like all trying to be in Flutterflow, trying to fix certain things. But once we got it out of there, and we kind of broke all these pieces into kind of getting back closer, like maybe basically losing layers of abstraction, we could get more control of it. And so this all looks better. You said you went from 1100 lines to 400 lines. That's great. The other thing is it fixed so many errors. Like it wasn't even working well. It was slow. It was laggy. We had a bunch of weird logic where you had to basically post and then you wanted to immediately see your post, or if someone liked your post, it needed sort of instantaneous updates. But also it's an infinite scroll. There could be thousands of lines of posts in this feed. So there's lots of little weird, quirky things. Like basically it was like an infinite scroll, but also we needed to have dynamic heights on the images because we have, sometimes there's an image, sometimes there's text, sometimes there's a video. So it's a very complex set of parameters. So not only did we like make it much simpler to work on and the code's cleaner, it actually like works. If you can imagine that, now that it's built right, it actually is much faster. It's more instantaneous and it's much more reliable now that we've cleaned that up. So I just want to give some context from like from the end user experience as well. So nice. You can keep going. Awesome.
Perfect. And I think this is this what Bruce said about layers of abstraction. I think this is very, very important. We even were discussing inside our Slack channel about a article regarding the great collapse of software quality or something like that. And basically, it's a article showing a lot of problems with the current state of how software development is working right now, especially with AI. But I think one of the points that's important for us right now is this of the many layers of abstraction. Like I like to think about it of layers of abstraction in terms of it's almost a lever connected to another lever, and then another lever, and then another lever, and then you are on the top pulling one of these levers, and these go like triggering all the levers from the layers below. And yeah, it's easier than it's, let's say, easier and faster to move the top lever than going down and working on the behind of the scenes, let's say. But this also comes with a lot of trade-offs, especially in terms of having less control over what you are building. And also, and which I think it's the most risky one, is you actually don't know what's happening. So that's one thing with Flutter Flow. We can know so much, like we can understand so much to a point that if you want to understand more, it's it's more worth it to just like migrate out of it and do it by yourself than try to understand their form of abstraction and work with their abstraction layer. So that's one thing we actually learned by doing and by exploring, because we really took the Flutter Flow to the limit. I really believe that we did a great job with it, and it was a very helpful tool. It really make things faster on the beginning, especially because all this started before we have tools like AI to help us with accelerating some part of the building. But now that times changed, and also that Tribe itself is a more robust application, we kind of grew out of Flutter Flow, and we kind of decided that we needed to have fewer layers of abstraction between us and what we really wanted to do. So that's an important thing to keep in mind, that every time that you are adding a layer of abstraction, meaning if you are adding a package that will be doing something for you, this is a layer of abstraction, and this is fine to a point, like, but you really want to think about it. Like, for instance, this page, we were using a external dependency to have the infinite scroll, to have a paginated infinite scroll. This component, the way Flutter Flow implemented, it was by actually importing an external dependency of another developer who built this component, and we were reusing it, which is fine. I think it's very useful to have this kind of tools, but it's independence in the end. So you don't know exactly how the developer builds. You don't know when they are going to update it. You don't know if they are going to update it. So every time that you are adding new stuff, you are adding these layers of abstractions. You need to take this into account. And in this specific case, we opted to remove this dependence completely and to build our own pagination, our paginated infinite scroller from the scratch. And it was one of the best things we could have done. It was like, it took, I think, 2 or 3 hours maybe, but the overall experience was a lot faster and a lot easier to use from a user standpoint and also from a developer standpoint. So yeah, it's worth to keep an eye on it. Sometimes you have to balance this trade between ease of use, fast, and the performance and the control you have over the code.
Nice. That's awesome. I know, like, we got about 5 or 10 minutes. I don't know what you wanted to hit on the last little bit here, because it's super helpful to kind of see this. Or if you guys, Luch and Ira, anyone on the team, want to see anything specific on this, what else did you want to touch on? You can jump in.
Okay, I will kind of just wrap this part. Actually, this whole slide right here is basically a summary of what I did. So I will just touch these 5 points, and then we go to cursor to IDE just to see how this is implemented in fact. So in terms of the migration itself, here is a small playbook that we have. It's map the page, identify responsibilities, navigation, filters, consent, and draw a desired widget tree. And this is really, you can draw it, like you can take like just a piece of paper and write it down and see, hey, I'm satisfied with how this should look. And then you have a goal in mind in terms of the widget tree itself. Then you extract the components, you map the components, then you extract them out of that big chunk of code. You isolate the state management, so we replace the FF app state with scoped providers or any other state management alternative that you think it's suitable for that component. You move the logic out by removing the Firestore queries or any type of logic that's embedded into the presentation layer. And then you can, and the five and last step is that you can add widgets or unit tests around the new components before deleting the Flutter Flow original. So that's something we also do. We keep the original component in the code base for a while, for like 3 4 weeks, until we see that everything is okay, that's working properly, and then we delete the old component. So key takeaways: migration will happen incrementally. Keep the generated widget around until parity is proven. Aim to shrink files and reduce the cyclometric complexity on each pass. I even added a link here to this part because I think it's very useful to think, to have this in mind when you are thinking in terms of code, because it allows to visually see the complexity of your code. So I really like this. So basically, every time that you have a decision, you create new nodes on your cycloaxiomatic tree, let's say. So, for instance, on this case, they have this very simple example of code, and here's how the complex the cyclosomatically complexity is drawn for this case. We have, I think we have one. Oh, this one I like to use it. So let me open it. So basically, it's a quick formula that you take your code and you pass it through, and it will give you a value of that you more or less can estimate the complexity of that code. So this is a mathematical way of measuring code complexity. So it's very useful because then you can basically, this is the kind of thing that you can take and feed to LLM. It will analyze the code and give you a value, and then you can compare it to the value from your refactor component. So this is a good thing to keep in mind. It's a useful tool to have while evaluating code complexity. And finally, clean architecture folders. And clean architecture folders are the destination, and refactor widgets are the bridge. So now let's take this last couple minutes just to see how this is looking in practice. So first of all, let me show the original component. Let me change the screen I'm sharing right now. Okay. Perfect. So this is the original component. This is the widget component. So as you can see, we have this state. It's basic for, it's necessary for every widget, but I think the most important part here to look at is this this build function that we have. So the build function is basically the main function of every widget. And if I close this, you see everything is inside the build function. So this is like crazy to give many things, because once you open this page, you really have to like look at all this to understand what this page is doing, like what are components of it, how it's laid down, what's the logic behind it. And it's just, and even like here we have like responsive behavior. Like if it's on a certain size, we are making things different. If and we also have like the logic here embedded into the widget, and we also have like, let me see if I can find, like you have dependencies on buttons from Flutterflow. Like, why do we even need a FF button widget? It's just a button. We don't need it to be from Flutterflow. So this is useful for the Flutterflow itself to reuse its component, but it's not for us anymore. So this is one example. And as you can see, overall, it's just very difficult to read, very difficult to understand what's happening, and it is a very chunky piece of code. And let's see now how we got this a little better. So this is the refactor component, and this is the build function for it. So a huge difference, and it's easier to read. You can come here and you see, hey, we have a fab. If the fab is expanded, we have a different, we show it or not. We have also a drawer, a app bar, and we have a body, and we have the fab, the floating action button that's associated with that screen. So let's see what's on the body. We can come here, and here is the body function. Like I said, very small, very clean, easy to read. I really like to have like this helper function. So if we come here, we just literally read. So we have a top web nav, then we have the group navigation, then we have the main component, and we have the bottom bar. We can click here, and then we go to the main contents. Let's see what's there. So we have a sidebar, nice. We have the main content column. Let's see what's on the main content column. It's right here. And here's the chunk of the build of the app. So even here, it's easier to read because we have separated it in different sections. So we have the feature content section. So we have a feature content widget. We have the category filter section. And finally, we have the post list section. So and also you have the create post section, which is just visible depending on the uh, on the uh, floating action button or if the user presses the button. But as you can see, even with like this chunkier component, we just can scan it and we can see, okay, that's more or less how it will look like, or that's what this page has as a content. So, and if I go here into the post list section, which is kind of the biggest thing if I believe here, then it's on a separated page completely. That's one of the things that makes it easier. So if I'm working just on the post section and I don't need anything else on the page, I can fit just this page, just this file to the LLM, for instance, or I can look at just this file, and this makes my life a lot easier to give my intents. So you can see just we have like the helpers functions here on top, and if we go here, we also have by the end of the file, here is the build component again, here is the build content, here is how it's being built. So we have a loader, then we have the if we have the placeholder, if the empty state, basically if there's no posts, and then we have a list view with infinite scroll, which is the list view that we built from zero. So if we come here and we go to our pre-refactor component, we were importing this infinite scroll pagination, and we are not anymore. We don't need this anymore, and we are not relying on an external dependence to build like the key part of our app. So this is a very important win that we've got out of this refactor. And yeah, I think actually we are kind of approaching the end of time, but I think this is a good overview of how we are thinking of it and how we are breaking things down and how we are making it easier for us to give maintenance, and also making it faster, better performance, and just better overall. So yeah, I think that's a wrap. Now I want to hear if you guys have any questions, if you guys want to take a look at anything specifically, but that's it for my side.
That's awesome. Yeah, and so, on a practical, you guys can drop any comments if you have them, or we'll wrap it up. But um, this was something that uh, I said a few hundred hours, like that translates to tens of thousands of dollars, right? If not more. And so building it much now, of course, we had to kind of iterate and figure out all these things in pieces, but now that we're at a lot larger scale, like this, these little inefficiencies are like, making a huge difference to cost and ultimately the experience of our customers. making sure it's a lot faster. So um, we'll have a part 2 or part 3 of this where we have Luchin talk about how we're removing all the Firebase out of this code and getting it over to SQL and API, and using a totally different backend. But it'll cool to see kind of the iterations of the code, first getting it cleaned up, because now we can actually work with it. And that's one thing I would highly recommend anyone who's doing any AI coding. Like, I recently was refactoring another part of the Flutter app last week, on the create post section, and uh, basically it was just struggling. Like, it was about 1,500 or 2,000 lines of code, and it just was not getting things done. So at first I just stopped, and for 30 minutes we just totally refactored the entire. We broke it into like 7 different pages, 7 different files. Pulled like common things out and made it much easier to work on. So it was only had maybe 3 or 4 5 files that were like a few hundred lines each, if not that. And all of a sudden, like, it just became so much more reliable, and then I could actually start working on it. So if you're getting stuck on these AI things, like, take time, fix the code, clean it up, make sure it's like logical. And this is true, like, if I was working on something and I was handing it to Jonata, or Jonata was handing it to someone else on our team, if you just built it clean and simple, it makes it easier for someone to read it, from top to bottom. But sometimes between AI or using these low code tools, like, the code that comes out is just basically unreadable. And so if you're having a hard time reading it, AI is probably going to have a hard time reading it. That's probably the moral of the story. But um, very cool. Yeah, Luchin said we had a comment there. One to give iterate on function class. Yeah, that's good. Okay, that sounds good. Well, we'll wrap it there. If you guys have any questions, drop a comment. We're happy to chat. We'll continue next week with back to some other different training and stuff. But yeah,